This is Geometry, Unit 5, Day 5. We're identifying special quadrilaterals. A quadrilateral ABCD has both pairs of opposite sides congruent. What type of quadrilaterals meet this condition? Well, the key thing they're asking here is both pairs of opposite sides. If a quad has both pairs of opposite sides congruent, what do we say? Then it is a parallelogram. Okay, a parallelogram, of course, by definition, has opposite sides parallel. But once you come up with that, you can then come up with the conclusion that the opposite sides are congruent, along with many other properties. Well, if a parallelogram has it, then so does anything that is a parallelogram. A rectangle, a rhombus, and a square. Our other shapes, trapezoid and kite, neither of them have opposite sides that are congruent, two sets of them. Quadrilateral JKLM has both pairs of opposite angles congruent. What types of quadrilaterals meet this condition? What do you think? If a quad has both pairs of opposite angles congruent, then it is a parallelogram. Okay, that was one of the properties that's true about a parallelogram. Once you have the opposite sides parallel, you could come up and prove that the opposite angles had to be congruent also. So a parallelogram would a rectangle has that, of course, being 90 degrees apiece. A rhombus, and of course a square. What is the most specific name for this quadrilateral ABCD? Well, what do you notice about it? It's clearly a quadrilateral because it has four sides. Each side has a tick mark. But notice we don't know much about the angles. There is not boxes in the corners. So even though you want to call it a square, there's not any information to say that you have right angles. You definitely have four congruent sides. If a quad has four congruent sides, then it is a rhombus. True, it's a parallelogram, but more specifically, the most specific name we could give it would be a rhombus. For our next one, is enough information given in the diagram to show that a quadrilateral FGHJ is an isosceles trapezoid? What do we see? Well, first of all, what's got to be true about an isosceles trapezoid? Isosceles trapezoid needs to have exactly one pair of opposite sides parallel. Well, do we have that? If we look at what would be considered the consecutive interior angles, the measure of angle G plus the measure of angle H should be supplementary, should add up to 180. So we have 102 plus 78, and of course that met that requirement. So we do have a pair of parallel sides. Now when we look at the base angles are congruent. And if we did the calculation, we would see that this angle was also 78 because these have to be supplementary. It's got to add up to 360 total. So if a trapezoid, we could be more specific, has congruent base angles, then it is an isosceles trapezoid. Looking at, we have our parallel sides to make it a trapezoid. We have our base angles. If you have one set that are congruent to each other, then the other set will definitely be congruent to each other also. Base angles are next to the parallel side, and then another set of base angles. What is the most specific name for quadrilateral QRST? Well, when we look at QSRT, we see that there are four sides, so it's definitely a quadrilateral. We notice that we don't have opposite sides congruent, so that's out. There's no evidence that we have anything parallel. But what you might notice is we have 8 and 8 and they're next to each other, 7 and 7 and they're next to each other. Those are called consecutive sides. If a quad has two sets of consecutive sides congruent, then it is a, what do we call that? A kite. There are lots of different properties about kites. Kites have diagonals that are perpendicular. Kites have one set of opposite angles that are congruent. But the main definition of a kite is two sets of consecutive sides congruent. Consecutive meaning side by side. Is enough information given in the diagram to show that the quadrilateral BCDE is a rectangle? Well, to be a rectangle, we know we need 4 right angles. And let's see, if we have a consecutive angles that are congruent, that's going to make not just congruent, but supplementary. That's going to make these parallel to each other, because these two are supplementary. We know that these sides are parallel to each other, which when we add it up to 360, or if we do another pair of consecutive interior angles, that makes this guy 90. So we do have 4 right angles. If a quad has 4 right angles, then it is a rectangle. That's pretty much the definition of a rectangle. 4 right angles. Okay, next what I'd like you to do is to take your blank sheet of paper, turn it so it's landscape. At the very top, we're going to draw a quadrilateral. Now remember, we're going to try to make this not a special quadrilateral. We want to try to make it have all the sides different from each other. Nothing special about this quadrilateral. We don't want any sides parallel to each other. We don't want any opposite sides or angles congruent. So this is going to be a quad. Now, what can a quad become? A quad can become a parallelogram. So now we're going to try to draw a parallelogram. So we're going to draw 2 parallel sides, and then we come up on, so I'm going to make my parallel sides a little bit longer. Then you want this one to be at that same angle or same slope. Okay, so what do you know about a parallelogram in terms of its sides? We have 2 congruent sides, or 2 sets of parallel sides. And we also have 2 sets of congruent sides. So that was 2 parts that we know that is true about a parallelogram. Now, what could a parallelogram become? Parallelogram could become a rectangle. So we're going to try to draw a rectangle, quadrilateral with 4 right angles. Okay, what do we know about this rectangle in terms of its sides? Really, the only guarantee that we have is 2 sets of parallel sides. we have two sets of congruent sides. That's the only thing we know for sure about the sides. Yes, the sides could be all congruent, but they don't have to be. Okay, or a parallelogram could come this way and be called a rhombus. So this time when we make our parallelogram, we're going to try to make the sides the same length. That would make them all the same. So what do we know about the sides of a rhombus? The sides of a rhombus, we have two sets of parallel sides, we know that, and we have four congruent sides. True, we have two sets of opposite sides that are congruent, but four congruent sides kind of implies that. Now, if you're a rectangle and a rhombus, then you are a square. Nothing wrong with that. So we have our rectangle property, and we have our rhombus property. So what we have here, we have two sets of parallel sides and in terms of the sides, we have four congruent sides. Wrong type of four. Now we're only focusing on the sides for this examples. So two sets of parallel sides, four congruent sides. Of course it has the right angles, but we're just going to focus here on the sides. Now we have a couple other shapes that we could talk about. If you're a quadrilateral, you could come over here. It's not a parallelogram, but we could be a trapezoid. And what do we know about a trapezoid? The only thing that has to be true to become a trapezoid in terms of its sides is what? Exactly one set of parallel sides. That's the only requirement that we have to become a trapezoid. Now, can a trapezoid be a rectangle? No, so we're not going to draw a connecting line to that. A trapezoid cannot be a parallelogram, so we're not going to draw a bar to that. but a trapezoid could be an isosceles trapezoid. And an isosceles trapezoid has exactly one set of parallel sides. It also has one set of congruent legs. The legs are not the bases. The legs are not the parallel sides. Alright. Then one last one to talk about. Over here, we have a kite. A kite is not a parallelogram, so it's not on the same links as that. It's not a trapezoid, so it's not on the same link as that. We have two sets of consecutive sides congruent. Alright, so there's a good little diagram that represents what's going on in terms of our quadrilateral, the sides of a quadrilateral. So that's what we're going to label this as. Sides of a quadrilateral. All right. Good job, everybody.